Hello, in this video we're going to talk about special case lines. That is, lines that pass through the point 0, 0, horizontal lines and vertical lines. Now in the last couple of videos we've talked about, I'll call them normal lines for want of a better word, because the majority of lines do look more like this. They don't pass through the centre, they are not horizontal and they are not vertical. And most lines of this form looks like this. Well, actually all lines of this form look like this. Y is equal to mx plus c. These lines, none of these lines will look exactly like that, although you could argue the first two do look like this, but not exactly. So I'll go through each of these. Let's look at a line that passes through 0, 0 first. We'll just pick a generic looking line. There's 0, 0, and a line that looks like this. Let's pick another point. Say this one here. I'll say this is a bit of an angle, so let's say 1, 2 looks about fine. That's okay with me. Or maybe there's more 2, 1, but whatever. It doesn't really matter for my maths. So we need both these. Well, how I'm going to get each of these lines is I'm going to use 2 points to get a slope and then get the equation. Or I'm going to try, because it's not going to work on the third one. So the 2 points would be 0, 0. Remember we have that, and the point 1, 2. Now I'll go a bit quicker on the second one, but this one let's slow it down, even though we've seen this in the last videos. And the equation, to get the slope, we get m is equal to y2 minus y1 divided by x2 minus x1. So we call this x1 y1, x2 y2. So this just becomes 2 minus 0 divided by 1 minus 0, which is equal to 2 over 1, which is equal to 2. Now, if you had put these the other way around, nothing stopping me doing this point first and this one second, you still should have got 2. You would have got minus 2 divided by minus 1, which is still plus 2. Okay, the equation of a line is y minus y1 equals mx minus x1. Again, x1 and y1 isn't stuck. It doesn't have to be this point. It could be this point if you want. It should work with both of them. Although 0, 0 will be the nicest and easiest to use. So if we fill in some numbers, y minus 0 equals 2 x minus 0. Let's see, y minus 0 is just y. 2 multiplied by x is 2x, and 2 multiplied by 0 is just 0. That's what the equation of a line through the center point looks like. It's a lot simpler. Instead of y equals mx plus c, the c is always going to be 0, because we talked about in the last couple of videos that when a line goes through the y-axis, that point is called the y-intercept. This number corresponds to that value, the y-intercept. This number will always be 0. If I guarantee the point goes through 0, 0, this number will always be 0. So that's an equation. It's just, and this is true for all of these. These are all easier. These are all easier than the standard one. If it goes through 0, 0, all you need to know is the slope. That's all that matters. If you tell me a line goes through 0, 0 and has a slope of minus 7, well, I know the equation is equal y is equal minus 7x. The equation of a line is always easy if you know the slope and it goes through the 0, 0. Okay, so that's what a line that goes through 0, 0 looks like. This is y is equal to 2x, looks like this. This would be going through the center. Y is equal to minus 1 or something. That looks more like plus 1, by the way. Y is equal, I guess, minus a half if my scales are right. A high one, this would be y is equal maybe 100x. A really shallow one might be y is equal, this is not meant to be on the line, y is equal minus 100 maybe x, something like that. Okay, let me rub this out and we'll do a horizontal line. Okay, a horizontal line, I'll just draw a generic one. I'll use a different color because it does get a bit confusing there. We'll just say a line like this. That's what I mean by horizontal, parallel to the x-axis. And we'll put in a number there, let's say 3. This is the point 3 there. Okay, so I need 2 points That's actually quite easy. If they just showed you this picture in a book, you should be able to get as many points as you want. One of the points would be 0, 3. That point there. If they told you again it's horizontal, any other point, this is 1 tree, 2 tree, 4 tree. Let's go 5 tree. That would be a point out here at 5 tree. So it should be easy enough to get 2 points on a horizontal line. Again, it's going to be easy to do it on a vertical line, although something is going to go wrong in the vertical one. So let's do this like we did last time. Let's get the slope. I'll go a little faster this time. y2 minus y1, 3 minus 3 is 0. 0 divided by anything is 0, so I don't have to do the bottom. But let's do it anyway. 5 minus 0 is 5. 0 divided by 5 is 0. And the equation of a line is y minus y1 equals 0 multiplied. 0 multiplied by anything is 0. I don't have to do the rest, but let's do it anyway. X minus x1. Like I said, this is 0 now. That's gone. We can ignore that. So this just becomes y minus 3. Or if we use this point, y minus 3. Won't matter. Y minus 3 is equal 0 multiplied by this is 0. Again, you can put in the number you want there. You put 0 in, or you can put 5 in. Doesn't matter. It's not going to change anything. So here's the equation. Let's get y in its own like we always do. Y is equal, add 3 to both sides. Y is equal to 3. That's the equation of a line. That one looks a lot different. Y is equal to 3 than the standard. Y is equal to mx plus c. But it's not that different, really. This is just c is equal to 3. And m is equal to 0. So it does actually look a lot like that one. Of course, you don't have to do this maths for this question. Hopefully, when you get more used to it, you see a horizontal line. If you know what this number is, here's the equation. A better way to think of this is an equation of a line is trying to tell you every point on a line. When there's an angle involved, it's very complicated. It looks like this. But for these straight lines, it's not very complicated. To describe every point here, all you have to tell me is y is equal to 3. I don't care what x is. X is every other number. 0, 3, 1, 3, 1.5, 3, 7.94827, 3. They're all points on this line. This tells me every point on that line, just like this. Okay, let's try and do the third one, vertical lines. And we're going to come into a little problem. Although you might see the easy answer to it. I'll let you think about it. I can't let you think about it. You need to pause the video yourself and have a think about it. But okay, let's do vertical lines here. We'll just draw a generic one again. We'll use a red line again, like that. And let's put in a point here. This point would be 4. Doesn't really matter. Just a vertical line is all I'm looking for. And 2 points on this line. Should be easy to find lots of them. Let's see, 4, 0 is 1. And then you can go ahead and pick any other one you want. This point, this point, this point. Any point you want. All you need to do is pick a number for y, really. So another point might be 4 and let's say here. Let's say minus 3. 4 minus 3. There's 2 points on this line. I've already said we're going to have a problem trying to do this if we did it the standard way. But let's try it anyway. We'll go m is equal, let's see, minus 3 minus 0. Well, that's just minus 3. Divided by 4 minus 4. There's our problem. This is impossible. This does not equal anything. We could say, by the way, that it approaches infinity. But we can't say it equals anything. Like, maybe you can use infinity at some stage, but it's not really going to help the rest of this question. We just have to give up on that point. If you get divided by 0, something's probably gone wrong in your maths. But let me try and continue. See what would happen. Y minus y1 is equal m. Well, here's a problem. We don't have a number for this. This is an impossible number. So it's not going to work. X minus x1. And yeah, it all falls apart there. There's nothing I can do. I can fill in these numbers, but this is an impossible number. So nothing happens. So that we can't use that way. But like I said, this is actually an easy answer. Think of the last part. A horizontal line. The equation of a horizontal line was y is equal whatever this is. Let's say it's a 3. Y is equal to 3. Very simple looking. This is just as simple looking. Except we're not going to be able to find y equals. That's why this failed, in fact. But an equation that describes every single point on this line still exists, and it's quite simple. It is just x, let's see, I've used red here. X is equal 4 in this case. That describes every point on this line. X is equal to 4 here, 4, 0. At this point, x is equal to 4. It's 4 minus 3. Pick any point we want. This point here, it's x is equal to 4. Y is equal, I don't know, it looks like 1.5. Every point, no matter where you go, x will always equal 4. So that describes this line perfectly. So you don't actually do the maths for this one or this one, because it's quite simple. It's just y equals 3, x equals 4, or any other ones. Let me do just a couple of examples here. I don't have numbers, so it's a bit confusing. But that would be x is equal, let's say, minus 2. This one here would be x is equal 4, it looks like. Let's put another one in. This line here looks like y is equal 1. And down here, y is equal minus, have I picked any lengths already? Minus 4 or so. It's as easy as that to do these vertical and horizontal lines. Okay, so that's the 3 special cases I thought I'd do a video on. I hope that helped. If you have any questions, put them in the comments below and I'll do my best to get back to you.